Hello and welcome everyone. So I'll be explaining you Codeforces 694 Div 2 problem B called Strange List. This was a pretty good one, to be honest. Let's jump into the statement. So actually, the problem statement says that we're given an integer, we're given an array of length n and an integer x to a brand new robot. So what actually does is that the robot will iterate over the elements and let the current element be q. If q is divisible by x, then the robot adds x copies of integer q by x at the end of the array and moves to the next element. Note that the newly added elements could be newly added elements could be processed by the robot later. So from one element, if the robot does its own step and creates those copies of elements, it can add at the end of the elements, and later if there time comes, then it might apply that values too. I mean the executable values that it just produced. So but there is a condition here. So if q is not divisible by x, then the robot shuts down. Now here's the tricky part. Here I actually thought that, okay, when the robot shuts down, then here they have clearly said one thing here, like, please determine the sum of all the values of the array at the end of the process. So here what I got tricked. I thought that, okay, if the robot has if the robot shuts down at some index, then till that index I will have to print the sum. Okay, I will have to print the sum till that index, but that's not the result. The main result is how many integers this robot has produced in that array, and you have to output the total sum of that, not till that index that it got shut down. Okay, I hope I made you understand. I will explain you with a bit of test case. That's why I actually got so many wrong answers, 3 wrong answers. I'll explain you. Let's explain this problem. Okay, here is also a this problem also gives a pretty good hint of complexity and analysis. So if you can determine the complexity of an algorithm, or you can analyze it well, this problem is very good one, because it actually goes down to something like this. I'll explain you. Let's take an example here. 4 2 let's say, I've got what, 4 4 6 8 2. Okay, 4 6 8 2. Now look, all of these values are actually divisible by x, right? So all of these values are divisible by x. Let's say that x is equal to 2. Now the main assumption is that you will try something of like brute force. Okay, it will be something of like brute force, but uh, you have to maintain something here, and you have to also analyze the complexity here. Normally when we do n log n type of solutions, what we do, we run out some for loops, and inside that for loop we run out a logarithmic complexity. But in this case, the complexity is still close to n log n. I'll explain it, but I'll just show you how I proceeded this problem. Normally this final array becomes something like this, right? This 4 6 8 2 2 2 3 3 4 4 1 1 1. I hope you I hope you know how I did that. Okay, I'll show you. Look, this 4, I will have 2 copies of 4 by 2, right? So here comes 2, and then when I traverse this, okay, this is also divisible by 2. Then I'll have 2 3s, and then I'll come here also, this is divisible by 2. I have 2 4s, right? I have 2 4s, blah blah blah, and 1 1 1 1. Okay, so this is how we'll do. This is how they have shown me, but I can draw that inside inside my array. I will do something of like, let me show you. I will check. Okay, I'll show you inside the code or outside. Let's see. um, so what I did here is, look, here's got the element 4, this is 6, this is 8, and this was 2, right? I actually first it is guaranteed that initial result will always be the sum of all the values, so I just counted initially the sum of all the values as AI, and I also took an array of count and initialized those values with 1. Okay, why I did that, I'll tell you why. But first, what I did was, okay, now when I actually, okay, let's take you to the code part. It might be better if I take you there. Okay, look, what I did here is, first I actually took n and x, and then I took the values, and as I told you, I took a count array, initializing each of them as 1, and initializing the initial sum, because this would always be at least the result will be the sum of all the values initially. I will stop my work when what? When AI is not divisible by x. This LLU is actually representing as a unsigned long integer. Now I actually run out a while loop. Inside that while loop, look what I just did. I actually look. You could say that normally what we do in n log n algorithm, like if I write an n log n times algorithm, what exactly happens? I traverse each of the elements and I do something logarithmic, right? But here the case is a bit different. What is different here? I'm not actually, if I say that, okay, I will initially divided by uh, x, as long as it is divisible by this array's value, right? So I could have done that. I could have done something like, okay, first I have got this value, then 4 by, and then 4 by 2, and then 2 by 2, blah blah blah. And for this next value, I could do something like 6 by 2, 3 by 2, which is not divisible. I could do something like that, but it does not work that way, because they have already told us, when I see it is divisible, I will copy that value at the end of the array and I will move to the next one, right? So I'm doing the same thing. Okay, I'm doing divisibility, but I am doing linearly for every value. Initially for every value, I'm doing one divisible operations each time, not for what not for just traversing one value at a time, but I'm trying to find out every possible value by checking the condition of divisibility by x, and I am doing this for each and every value each time, not for one values until it gets not divisible. I hope I made you understand that. I will explain you more with the code part. Now look, when I do here while loop, inside that while loop, this while loop is actually, you could sense this while loop is actually working as n. Okay, and this part here is working as log n. Why this part? I told you, what I'm doing. I'm doing the each of the for each of the values, I'm doing the divisibility, which means I'm iterating the logarithmic way. In the logarithmic way, I'm not contributing for one value. I'm not contributing for one value until it gets. I am contributing for each of the values, and I'm traversing just like the robot. So I'm working just like the robot. You could sense that. Okay, I'm working just like the robot. Well, what is it? Just I'm checking the divisibility. If it is divisible, then I just divisible by x. I just divide. I just divide it by x, and this is the value that I will get after the end of the array. Okay, now I also told that when I accomplish one step, I have to add that value too. So that's exactly what I did here. Count I equal to count I times x. Now why is that line? What is this line for? You may ask. Okay, and why am I even taking this array of count? This actually needs to, because you are moving from left to right. So if left's count is finished, then right's count will be new, right? For the right values, the count will be new. So that's why we have to take the initial count array and initialize it by 1, because I'm multiplying now. This is also a burning question, why I'm multiplying it by x each time. I'll show you an example why I'm doing this. Okay, let's say we have two sixes, okay, and we are given x equal to 2. Now when you do operation for this, what exactly happens? 6 is divisible by 2, which means 6 by 2 is equal to 3. So if I follow the operation, the next array would something look like this, right? Exactly. And if I do okay, let's take you to a more good example. Let's think that I've got two elements, 4 and my x is 2. What I do next time, I will do, okay, this is my 4, so the next step would something look like this, right? And then I traverse here, and the next step something looks like what? This. What actually happens, look, x is 2 and I'm dividing it by the value, but what happens here? This count is multiplying by this count. That's exactly what I'm maintaining. Each time I have to maintain that. Look, why this happens? Because 4 is 2 times. 4 is what? 2 times. I've got 2 times of 4. Exactly what happens here. So, so what we did here is just multiplying it. Multiplying this multi, and finally we're just counting how many times it will occur. So, and calculating the value that has been created now. Like just imagine imagine this is 4 and I'm doing what? 4 by 2. Okay, imagine this is 4, this is 4. Okay, I'm doing 4 by 2. What comes? 2. And count of 2. Now what was the count of I? Count of I is count of I was 2. So 2 times 2 is what? 4. That's exactly what happens here. 2 times 2 is 4. So uh, this so for each and every index I'm maintaining a count array, because this number, when it is divisible by 2, this value splits into 2, number 2. And then for the next one, if you still as we are I mean doing the addition operation by multiplying, that's why we need to maintain the count. And that's exactly what we and why we need to do that. Why we need to do this part? This part is needed because when this value, let's say I've got 8 and 8 becomes 4. When 8 becomes 4, it becomes actually 2 4s. And then when 4 becomes 2, it actually becomes what? you will also traverse this, right? So it does make sense that this will become 2 and this will become 2. At some point you have to traverse that. Okay, this will also come when you traverse the array. So that's exactly what is happening here. That's why we have to multiply here for each and every indexes. And for this operation, ai times count I, this is actually doing the additional operation by multiplying. I mean, like this. If 4 is 3 times, then I just do 3 times 4, not adding and increasing the complexity by adding more and more. So that's exactly what happened here. And finally, if the condition breaks, if it's not divisible, then I'm just giving a track here and breaking out from the loop, and finally adding the answer. Now remember, this answer includes all the values that are present in the current array that I have created, that the robot has created. So that's how actually you will do that, do this problem. So uh, I hope I made you understand, and till next time, goodbye.